Hello and welcome back to Math with Mrs. Becker. Today in Algebra 2, we are jumping into section 3.5 and the wonderful world of three dimensions. Now in real life, if you are ever using things like Google Maps or you guys probably never had a Garmin. They were like little things that you put in your car and you'd put in the address and it would tell you how to get to your destination. Well, in order for things like that to work, where you have that global positioning system, those GPSs, you have to have three dimensions. They need to know the latitude, the longitude, and the elevation to give you accurate directions. Okay, so it is very important that somebody along the line created mathematics that did have three dimensions, so that way these GPS systems can exist today. Okay, there is something called a three-dimensional coordinate system, okay? This is gonna get a little bit trippy because you are used to a coordinate plane. You guys, this is called three-dimensional coordinate system, also known as coordinate space. This is what it looks like. Now, obviously, when we go ahead and start graphing, I don't expect that you're gonna be able to draw this thing in 3D, okay? I can't draw this thing in 3D. So what we do, okay, you are used to a coordinate plane. Now you can't go ahead and put X and Y because you guys, this is where it gets wild. This is now X. You're gonna go ahead and draw a diagonal line that is going up to the right and down to the left. You are picturing this as this is being forward, like it's coming to you. Here you are. Yay, there I am. This line is coming to you. This line is going backwards. This is now your X. Y is now left and right. Z is now up and down. So again, X is forwards and backwards. If it's positive, you go forwards. If it's negative, you go backwards. Y is now side to side. If it's positive, you go right. If it's negative, you go left. Z is up or down. If it's positive, you go up. If it's negative, you go down. So what we have now are called ordered triples. Ordered pairs are what we had before because we only had two things. We had X and Y, so that's a pair. Well, now we have X, Y, Z. It is called an ordered triple. And just like an ordered pair, it's important to always have the X and then the Y. In an ordered triple, it's important to have X, Y, and Z. Okay, so again, they're just introducing that we're going to take this to a whole new level. When we draw it, you guys, this is what it looks like. So it's a coordinate plane, draw the diagonal, but you have to remember this is X, this is Y, because we now added a Z axis that goes up and down, okay? When you are graphing, what is very important is that you show the path that you take. So you do start at the origin. This is the origin, okay? Notice that they don't have any tick marks, okay? That's why the path is so key. So what happens is you start at the origin. The X is positive, so I go forwards 3 units on the X. The Y is left and right. This is negative, so I go left 2 units. Then I go up 1 unit. So from the origin, you have to show, okay, I traveled forwards, then I went left, then I went up. That's where I'm approximating that point would be. So you do have to show the path you take. And I know this is new, and with us being not together in the classroom, I went ahead and kind of gave you direction so you can go back and look and say, all right, how did I do this? Let's look at a few more. So you're just plotting points, which is kind of cool. If I am looking at the next one, I want to plot the ordered triple 2, -1, -3. X goes forward and backwards. This is positive, so I go forwards. Y goes left and right. This is negative. The negative direction is left. This is up or down, so I go down. So from here, I go forwards, left, down. You show the path, approximate where you feel that point would be, and you're done. Okay, we can graph point C. The X value is forwards or backwards. This is negative, so I go back. This is left and right, so I don't go left or right. This is up or down. It's positive, so I go up. So this point from the origin, I go backwards a unit, and then I head up. So again, showing the path you take is what's really important here. Okay, a few more just because it's a new topic. The first value is positive, so I go forwards. The second value is left or right. We have a positive value, so we cut to the right. The last value is up or down. This is a negative value, so I go down. You always start at the origin, so I go forwards on the diagonal, cut to the right, travel down. That's where I'm approximating that point would be. Okay, here's another one. Forward, because the x value is positive. Left, because the y value is negative. Up, because the z value is positive. So I travel forwards, left, up, there's the point. Okay, so that's how you plot just a single order triple. Now this is called an intercept, and we're going to go ahead and get into intercepts in just a minute here. When you have zeros in two of the locations and a number in the other location, that's how you get an intercept. So here, I'm not going anywhere on the diagonal, not forwards or backwards. I'm not going left or right. I am just going up 3. This is a z-intercept because your point falls on the z-axis. This occurs when you have zeros in the other two locations, okay? Let's go ahead and make that transition from single points to planes. Recall that the graph of a linear equation in 2 dimensions is a straight line. So if we are graphing in a coordinate plane that has x and y, and our equation has x and y, we get a line. Well, when we graph in 3-dimensional space, what happens is you're actually graphing a plane. A plane is defined by 3 points. What we want to do to find those 3 points are to find those intercepts. Now, a plane is a 3-dimensional object. So once we have our intercepts, what we need to do is connect them and shade. Because by shading it, we're saying, okay, we realize this is a 3D object. Okay, let's go ahead and do that. If they want you to graph an equation that is 3-dimensional, meaning it has x, y, and z, this is where you have to find the intercepts, okay? What we did previously, we were just graphing an ordered triple. This is 1 point. That's why we just show the path and show where that 1 point would go. If they want you to graph an equation, in order to graph an equation with 3 variables, you need 3 points. So I find the intercepts. If I put in a 0 for x and a 0 for y, z would be a -6. Well, if I put in a 0 for x and a 0 for z, the x cancels, the z cancels. To solve for y, I'd have to divide by -3. -6 divided by -3 is 2. If I put in a 0 for y and a 0 for z, I would have 2x equals -6 because those would be zeros. If I divide by 2, -6 divided by 2 is -3. Now what I do is I plot those 3 points. Now each of these points should be on one of either the x-axis, the y-axis, or the z-axis. So don't go forwards, backwards, don't go left or right, go up or down. It's negative, so I go down 6. 0, don't go forwards, backwards, right. Go to the right 2. Don't go up or down. Negative, I go backwards 3. Okay, so now, again, this is a 3-dimensional object. So you go ahead, and I know this is kind of a little sliver here. You connect those points and you shade to say, okay, here's where my intercepts fall. And again, a lot of this is estimating because look at these graphs. They don't have the tick marks where you can even count. It's estimating. Like I had to make sure that I went further down here because that was -6. And I went backwards more than I went to the right. Okay, so it's just kind of eyeballing it and doing the best you can. But this is how you would graph a plane. Okay, let's do another one. If they want you to graph this equation, that's when you need your intercepts. So if I put in a 0 for x and a 0 for y, this is what I would have remaining. 2z equals 4. Divide by 2, 4 divided by 2 is 2. If I put in a 0 for x and a 0 for z, the x and the z would cancel. I would have -4y equals 4. If I divide both sides by -4, +4 divided by -4 is -1. If I put in 0 for y and 0 for z, I have x equals 4. So in order to graph an equation with 3 variables, you need 3 points. Don't go forwards, backwards. Don't go left or right. Just go up 2. Don't go forwards, backwards. Go left 1. Go forwards 4, not left or right, not up or down. So again, kind of tricky to connect these. A lot of times they're nice big triangles for you. I must have picked some crazy equations for the notes. However, it's good for you to see that this happens. Okay, so if you're like, how the heck do you connect it? You do the best you can. You show that they're all together. You shade to show that, hey, this is a 3-dimensional object in coordinate space. Let's keep on going. Oh, yes, story problems. Okay, so if you have 3 variables, you can solve like even cooler story problems. So let's check this out. Those of you who are in track, we can figure out some relay scores. Track relay teams. They score 5 points if they have a first place finish, 3 points for a second place finish, and 1 point for a third place finish. Lucy was on a team, and Lucy's team scored a total of 30 points. Write a linear equation that has 3 variables. The reason why we have 3 variables is because we have 3 places. We have first, second, and third place. Okay. Let F represent the number of first finishes, S for second, T for third. So you get 5 points for first, plus you get points for second, 3 points for second, plus you get points for third, 1 point for third. Lucy's team scored 30. There's an equation that has 3 variables, so that is a 3-dimension equation. If Lucy's team finished second in 6 events, so that means S equals 6, and third in 2 events, so T equals 2. How many events did they end up getting first? So we just go ahead. Second, they earned 6 times. Third, they earned 2 times. So we replace these variables with the numerical values. So 5F plus 3 times second place finishes were 6, plus 1 times third place finishes, they got 2. Order of operations, I can go ahead and multiply those. So 5F plus 3 times 6 is 18. 1 times 2 is 2 equals 30. I can combine my 18 and my 2 because they are like terms. So 5F plus 18 plus 2 is 20. Minus the 20 to the other side. So 5F equals 10. So F equals 2. They had 2 first place finishes. Let's do one more. Steve purchased $61.50 worth of supplies for a hiking trip. The supplies included flashlights. They were $3.50 each. Compasses. They were $1.50 each. And water bottles for 75 cents each. Write a linear equation with 3 variables to represent the situation. Let X be flashlights, Y be compasses, Z be water bottles. Okay, so flashlights is X. Flashlights were $3.50. So $3.50 X. Plus he bought compasses. Compasses were $1.50. $1.50 Y. Plus water bottles. Water bottles were 75 cents. Z. Steve purchased $61.50. There is your equation. Now it will tell you 2 amounts that Steve bought, and we can go ahead and find the third. Steve purchased 6 flashlights. Flashlights is X, so X equals 6. 24 water bottles. Water bottles was Z, so Z equals 24. How many compasses? So that's what we're trying to find. We have to solve for Y. So I go back to the original. We know that X is really a 6, plus 150, we don't know why, plus 0.75, Z is 24. The whole thing has to equal 6150. So now if I go ahead and do my calculations, if I take $3.50 times 6, he spent $21 on flashlights. We're not sure how much money he spent on compasses. 75 cents per water bottle, he bought 24 of those, so that was $18. We know we spent $61.50. I can combine my like terms. If I take 21 plus 18, I have 39. So 39 plus 150y equals 6150. minus the 39 to the other side. So if I take 61.50 and I minus 39, I have $22.50. Go ahead and divide that by 150. So 22.50 divided by 150. Steve bought 15 compasses. He wanted to really make sure that he did not get lost on his hiking trip. So you guys, that was 3.5. 3 skills. Can you graph an ordered triple? If they just give you an ordered triple, you just have to show the path you would take, and your final answer is just 1 point. If they want you to graph an equation that has x, y, and z, in order to do that, you need 3 points. So you find the 3 intercepts, connect them to show that you realize that this is a 3D object called a plane. Then we have story problems, where you're looking at 3 different variables. What you'll have to do is create an equation. Once you have your equation, they will give you 2 values. You fill it in and find the third. All you have for 3.5 is a book assignment. It is on pages 216 and 217 in your textbook. I want you to go ahead and look at numbers 1 through 24. I hope you guys had a great time warping into the 3rd dimension, and I'll talk to you soon.